Hi guys, welcome to the machine learning section. So far, we have set the foundations and covered Python essentials along with its powerful capabilities in data analysis and data visualizations. It's time to move on to the next extremely important section, which is machine learning. In this section, we will often reference to the following resources: Machine Learning by Kevin P. Murphy, An Introduction to Statistical Learning by Gareth James, and of course the official documentation of Scikit Learn, which is the Python library for machine learning. Although the lecture notes and the exercises are self-sufficient, however, you are always welcome to explore the suggested material to learn more. So, moving forward, the first question is, what is machine learning and why we need this actually? Think about it. How much data we are generating on daily basis? Like we are texting, we are using social media like Facebook, Twitter, we are speaking, we are writing and publishing, and there are several other ways where we are generating huge amount of data. So we are actually in the era of big data. There are about 1 trillion of web pages and more are adding daily. Around 1 hour of video contents are uploaded to YouTube only in every second. If we consider transactional data, only the Walmart handles more than 1 million transactions per hour. So the databases are continuing to grow in petabytes and more. So we have humongous amount of data. And to handle this humongous amount of data and related issues, something intelligent is required. A set of methods that can automatically detect patterns in the data and predict future data or perform other kind of tasks. Machine learning provides this all. There are tons of application of machine learning that includes targeted marketing, real-time ads on the web pages, and this is very common to see when you are browsing on internet. Fraud detection is another field, credit scoring, insurance, and next best offers. Like if you have a better credit score, you may get better offer. So pricing models for new products, text analysis, email spam, and so many other examples. We will explore lots of these with hands-on projects in this course. So the machine learning process involves some steps. The first step is data acquiring. Data may have lots of features which are also called dimensions or variables, and we may need to clean that data. The next step after data acquiring is data cleaning. In this process, we extract the useful data and reorganize the data into a right format. After this, we split the data into test and train set. After splitting, we train our model on the training dataset and then test the trained model on the test dataset. Keep it in your mind that this is an iterative process, and we repeat this process until we get the best fit to our data. Once we have the best fit to our data, our model is ready and we deploy that model. Machine learning has mainly three types: supervised or predictive learning, unsupervised or descriptive learning, and the third one is reinforcement learning. Let's discuss little more on these types in the coming slides. Let's talk about supervised learning first. In this type of learning algorithm, a set of labeled data based on known features, also called dimensions or variables, is provided. Algorithms are trained using labeled examples. Simply, the learning algorithm receives a set of inputs along with the corresponding correct outputs. It then learns by comparing its actual output with correct outputs to find error. The algorithm then modifies the model accordingly and get the best deployable model based on the training data. Supervised learning is commonly used in application where historical data predicts likely future events. For example, in a very simple setting, the algorithm is given heights and weights as features along with labels as male and female. A model trained on the data with known features and labels can be used to predict the gender of a human if the unlabeled data are provided. Another very common example is the prediction of house price using a model trained on features such as number of rooms, area, floor, and price as a label, which is also called target value. So the supervised learning problems are grouped into classification and regression. Let's talk about unsupervised learning now. In this type of learning, only inputs are given with no historical labels or target values. And the goal is to find interesting patterns in the data. This is sometimes called knowledge discovery. Unsupervised learning is much less well-defined problem since the system is not told the right answer and the algorithm must figure out what is being shown. Popular techniques include self-organizing maps, nearest neighboring maps, k-mean clustering, and singular value decomposition. The unsupervised learning problems are largely grouped into clustering and association, and we will talk about these type of problems with practical examples in this course. The third type of machine learning is reinforcement learning, which is somewhat less commonly used. This is often used for robotics, gaming, operational research, and navigation. The algorithm discovers through trial and error which action yield the greatest reward. There are three primary components involved in this type of learning: the agent, which is actually a decision maker; the environment, everything the agent interacts with; and action, what the agent can do. A typical framing of reinforcement learning scenario is an agent takes action in an environment which is interpreted into a reward and a representation of the state, which are fed back into the agent. The agent will reach the goal much faster by following a good policy. Hence, the goal of reinforcement learning is to learn the best policy. Consider how baby learns to walk. So, we got a brief overview on types of machine learning. So how we are going to learn these algorithms and what will be the strategy in this section. Of course, we will learn range of algorithms using real data in this machine learning section. Our learning strategy will be very practical, very simple, and very effective. First of all, there will be a video lecture on overview of the topic and the optional readings. Second, we will have a demonstration lecture using Python on the topic with data. Third one is the practice our skills. At the end of each topic, we will have project and assignments to practice the skills. In this way, you will get an opportunity to think how to explore data and how to apply machine learning algorithm on that data. After that, we will go through the solution of the project as well. Our practical teaching methodology will make the things much easier to understand and follow the steps involved. We will actually perform machine learning tasks on the dataset in this section. Couple of important notes. Remember, it takes time to learn, especially when it comes to the machine learning. You need to be patient and committed to learn and understand. Remember, machine learning is one of the major skills you need to become a successful data scientist. The resource links provided in this section are great to learn the basics in the field. However, not one single resource can be considered as a reference for all machine learning topics. The lectures are prepared using all the references and much more. You are always welcome to post your questions in question and answer forum, and we will be pleased to guide through the topic. So yes, machine learning is fun. Bear with me. You will find machine learning very interesting, fulfilling, and rewarding. Moving forward, to do machine learning in Python, we need to install the library. So the Scikit Learn is the most popular machine learning package for Python. Scikit Learn has a lot of built-in algorithms as well. To do machine learning, you need to install this package because we will use this package in this section. So if you have Anaconda distribution installed on your computer, go to the command line or terminal and type conda install scikit-learn. If you don't have Anaconda distribution installed, you can use pip command. Pip install scikit-learn. Once the package is installed, we are ready to move on. Let's jump on to the next lecture to get hands-on in machine learning. The last very important thing, Scikit-Learn official cheat sheet can be downloaded on this provided link. However, the copy of cheat sheet is also included in the course material. So, see you in the next lecture with installed Scikit-Learn. Good luck.